All right, today's lesson is 9.3, Connecting Graphs and Rational Equations, pages 457 to 467 in your text. Our course outcome is 30.11 again, demonstrate understanding of radical and rational functions with restrictions on the domain. Our lesson objectives, number 1, to be able to solve rational equations algebraically. That's the big one today. Number 2, to be able to use graphing software to verify the roots of a rational equation. And number 3, to be able to find extraneous roots to a rational equation. So in previous lessons, we were able to find the x-intercepts of a rational function by simply factoring the numerator of the rational function. And now we'll be dealing with more complicated rational equations. So it may be very difficult to actually factor our numerator or even manipulate the equation to get a single fraction. So here's an example. It says, determine the roots of the following equation. We have 14 divided by x minus x plus 5 equals 0. So when you're solving rational equations, your best bet to solve for x, to find your roots, is to get rid of fractions. No one really likes fractions anyway, so we're going to multiply every term in this equation by something that will rid us of the denominator, which happens to be x. So for this example, we're going to multiply every term by x. So we're going to multiply that term by x, we're going to multiply this term by x, that term by x, and that term by x. And in doing so, we end up with these two x's canceling off, so we get 14. We have negative x times x, which is negative x squared. And we have positive 5 times x, which is plus 5x. And 0 times x is still 0. So we've been able to manipulate this equation, get rid of any sort of fractions, and we're left with a quadratic, which we should be able to solve quite easily. The only problem is that we have a negative x squared. We always like that to be positive. So we're just going to move everything over to the right-hand side. So that x squared now becomes positive. The 5x now becomes negative, and the 14 also becomes negative. So to solve this quadratic, well, we just factor. So we're trying to find two things that multiply together to give negative 14 and add together to give you negative 5. And that would be negative 7 and positive 2, which means my answers are x equals positive 7 and x equals negative 2. Here's our second example. It says solve the following equation to the nearest hundredth and verify by using graphing software. So 2 minus 3x over 2 equals 1 plus 4x minus x squared all over 4x plus 10. So again, pretty complicated to try and factor and find our x-intercepts. So what we're going to do is multiply every term by something that's going to get rid of our denominators. Now we have two fractions in this case. So what you need to do, and you want to probably make a note of this, is you need to factor all of your denominators, no matter what. And so we can take out a greatest common factor of 2, and so we're left with 2x plus 5. So now we need to choose something that's going to get rid of all these denominators, so both of these. And so we're going to multiply each term by 2 and 2x plus 5. So we're going to multiply the right-hand side by it, and we're going to multiply both terms on the left-hand side by the same thing. So when we do that, we get, on the left-hand side, we get 2 times 2 times 2x plus 5. And then we get negative 3x over 2 times 2 times 2x plus 5. And then on the right-hand side, these 2 times 2x plus 5s cancel each other out entirely. So we end up with just the 1 plus 4x minus x squared. Over on this side, we have 2 times 2 times 2x, which is 8x. We have 2 times 2 times 5, which is 20. Here we have these two 2's cancel each other out, so we're just left with negative 3x times positive 2x. That's negative 6x squared. And negative 3x times positive 5, which is negative 15x. And then on the right-hand side, we're left with 1 plus 4x minus x squared. So we've gotten rid of our fractions again, which is a really good thing because it would be very difficult to solve this equation otherwise. And now we just need to move everything to the one side, so we'll say the left-hand side, and we will make it equal to 0. So in doing so, we get negative 6x squared, and then this negative x squared, when we move it over, it becomes positive, so that's negative 5x squared. We have 8x minus 15x, which is negative 7x, plus 4x is 3x. And then we have 20 minus 1, which is 19. So now we get a quadratic. You can't factor this thing at all. I've tried, and you're just going to get crazy decimals. So what you want to use is your quadratic formula. And if you remember your quadratic formula, it is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And when you use that, you'll find out two values for x. And those two values for x are 1.138 and negative 3.338. And those are your two answers. Now I noticed that I just made a mistake. This should be a positive 11x. And that's my fault. So we have negative 5x squared plus 11x plus 19. You plug those values into your quadratic formula and you get two different answers. So next thing we're going to do is verify by using graphing software. So we're back to Desmos.com as our graphing calculator, and I've plugged in our two sides of our equation. On the left-hand side, we had 2 minus 3 over 2x. So hopefully you recognize that as a line. So if we were to graph it, it makes a nice line right here. And the right-hand side of our equation was 1 plus 4x minus x squared, all divided by 4x plus 10. And since we're working with rational functions, hopefully you see that as a rational function. So there should be some curvy parts and some asymptotes. And when we graph that one, we also have, there's the curvy parts, and there would be some asymptotes in this graph as well. Now, we have our 2 points of intersection, which we just found. And the 1 point of intersection was 1.138. That was one of our answers when using the quadratic formula. And the other one was negative 3.338. So these were the two answers we found using the quadratic formula, which just shows that is the solution or the answer to our rational equation. So our final example says solve, check your answers to make sure none are extraneous. So remember, an extraneous answer is one that when you check it, it doesn't work. So we have x plus 3 divided by 2x minus 6 equals 2x minus x divided by 3 minus x. So again, our first step always should be to factor anything that we find in the denominator. And so we get x plus 3 divided by 2 over x minus 3. Now over here we have 2x minus x, but we have a 3 minus x in the bottom. So we can change that to an x minus 3 if we multiply it by a negative 1. And so this 3 minus x actually turns into a negative x minus 3. So that, since it was already negative and now it's another negative, that changes our equation to make that a positive sign. So you have to be able to recognize that 3 minus x, x minus 3 are opposites, so we can change one to the other by multiplying by negative 1. So we have 2 times x minus 3 on the left-hand side of the denominator, and we have just an x minus 3 on the right-hand side of the denominator. So what we need to do is multiply each term by 2 and x minus 3. That will get rid of everything in our denominators. So on the left-hand side, when we multiply it by 2 and x minus 3, they just cancel out. And so we're left with just plain old x plus 3. On the right-hand side, we have to multiply 2x by 2 and x minus 3. And then we also have x divided by x minus 3 multiplied by 2 times x minus 3. And so what happens here is that the x minus 3 here and the x minus 3 cancel out. And as a result, we get x plus 3 equals 2x times 2 is 4x times x is 4x squared. 4x times negative 3 is negative 12x. And then we have x times 2, which is 2x. We move everything to the same side. We have negative 12x plus 2 is negative 10x. We subtract another x, we get negative 11x. And then we also move the 3 over here, so we get a negative 3. Now, you could use the quadratic formula again, but this thing you can actually use decomposition. So I'll give an example of decomposition. Two numbers that multiply together to give you 4 times negative 3, which is negative 12. And so we are looking for two things that multiply to negative 12 but add to negative 11. And that would be negative 12x and positive x. And then we group these first two terms and take out a greatest common factor. which is 4x, and we're left with x minus 3. And then over here, since we already had an x minus 3, you can think of taking out like a greatest common factor of positive 1. Now we see that there's an x minus 3 in both of these terms, so we take out an x minus 3 as one of our factors, and the other factor is whatever is left over, 4x plus 1. So we get two answers, x equals negative or positive 3, and x equals, when we solve this little factor, make it equal 0 and solve it, and we get negative 1/4. Now, we have to check for extraneous answers in every question. If we take this x equals 3 and we plug it back into the original equation, we would get a 0 in the denominator here, and we would get a 0 in the denominator there, which means it is an extraneous answer. We got it as an answer by doing the algebra, but we can't use it as one of our answers because when we plug it into our original equation, we'll get a 0 in the denominator, and that's not allowed. We can, however, plug in a negative 1/4 here and still get an answer, so this is our only answer, x equals negative 1/4. So in summary, when solving a rational equation, your best bet is to factor the numerators and denominators of each fraction and then multiply each term by those denominators. Remember that we're doing that in order to cancel out any fractions. Solving a rational equation algebraically will give you the location of the x-intercepts of that function, or in the case that we had for our second example, where those two functions will cross each other. And remember to always check your answers to make sure that they are not extraneous. This could be by substituting it back into the original equation, or if you wanted to, you could check your answers just by using graphing software and graphing the function that you see there, or both sides of the equation. Our assignment, pages 465 to 467. Good luck, and we'll see you in class.